And hello everyone, it is March 28th, 2016, and I believe we are live. Hello, Jack Heslin here from J3D, J3DServices.com, talking about today's daily update in 3D printing. Got my mount correct here. Today we're going to talk about something just for a few minutes that is something that I bump into a lot when I talk to people who in some cases are even in the manufacturing or educational sector, people who are familiar with 3D printing, but still have some conceptions about limitations on the materials. And I'll give you an example of what I'm talking about here. So this is, hold it up here so you can see it very clearly. This is a very simple bracket that was made for a very, very particular application. And it is strictly a prototype or a model. This was printed on a MakerBot replicator. It is true green PLA, and in the actual application, this does not have what it needs. This is a not strong enough material that it would hold up. So after the company doing this would get it just right, they would then still go out to a machine shop and have it made out of a stronger material, probably some kind of stainless steel or something. And I talk to people, even people who are mechanical engineers and industrial designers, who still think that this is a lot of 3D printing, and they're aware that there are other applications with metals, but can you really get them into a production environment? And I came across something recently. It's actually not a news story. It was a story from last summer about how NASA is using 3D printing in their next generation rocket. And I have here a slide, two slides that I'm going to show you, and get my sleeves rolled up, and we're doing a big technical step here. I have to double tap on the screen to reverse the camera angle. This is incredibly complex. So here goes my double tap. Oh, get my finger out of the way so you're not all looking at my finger. Now double tap, and there is my screen, and this is 37 seconds of a really boring video, but hold on here, just bear with me. This is from a NASA test last July, as you can see. So this will just go for a few seconds. And we're coming to the end, almost getting there. Hello, Devinder, thank you for joining. And now the next thing, just to take a look at here, what did you just see? The NASA rocket fuel pump, sorry, let's get this better bracket here. That was spinning at about 90,000 RPM, generating 2,000 horsepower. That fuel pump, pull this back so you get a better picture of it, capable of delivering 1,200 gallons of liquid nitrogen a minute. So in a 37-second video, we should have saw, I guess 600 something gallons go by. The liquid nitrogen is minus 240 Celsius, can generate 35,000 pounds of thrust. And this fuel pump, made of hundreds of parts, is made with 45% fewer parts than if it was manufactured traditionally. And that's all posted on the NASA.gov website from August of 2015. Now I'm going to double tap, and you're back to being stuck looking at me. Sorry about that. But there's a point to this. Back on our trusty bracket. The point is, are there really a lot more extreme environments than having to move 1,200 gallons a minute of liquid nitrogen at minus 240 degrees Celsius through a fuel injector? There aren't a lot more extreme environments than that, and yet it was done with a large hundreds of parts, many of them 3D printed. So I wanted to get this out there for people to understand what's coming. The big reason you don't see 3D printing in more production-oriented environments at car companies and appliance companies is because the process is slow. Not because the materials are limited. The materials are extraordinary. And the material sciences developments in 3D printing are really pushing the boundaries here. But in the coming years, you've got Carbon 3D, you've got Hewlett Packard, you have XJet, who are all tackling head-on this issue of speed in 3D printing, and they're all making a lot of progress. So I think between what the materials can do and the speed of 3D printing that's improving and increasing, we're going to see some more of these incredible applications in more traditional industries. NASA doesn't have to get a fuel pump to market in a particular time frame. They launch the rocket when they know it'll be safe and they can do it. So I thought that was an important thing to share, that it's not just about basic plastics, even though I still meet people in the manufacturing, architecture, educational sectors who aren't aware of the tremendous advances being made in some of these applications in 3D printing. So that's your Monday Daily Digest. I hope everyone had a great Easter for those people who celebrate the holiday. And thank you, Devinder, for saying that was an amazing insight. Thank you very much. My name is Jack Heslin. My company, J3D, j3dservices.com on the web. We provide MakerBots, Airwolfs, Mendelmaxes, printing and scanning services. If you have a story you'd like to share, we'd love to hear from you. And if you'd like to talk about how these 3D solutions benefit your organization, please go to our contact form, fill it all out. We'll get back to you ASAP, or give us a call, 844-J3D-MAKE. And we'd love to catch up with you. So have a great rest of your Monday, and we will talk tomorrow. Thank you all very much. Bye-bye.